Welcome to the lecture on properties of real numbers. Properties of real numbers are rules that allow us to do different things with real numbers. And these are properties that you need to have memorized. The first property that we're going to talk about is the commutative property, and there's a commutative property of addition and also a commutative property of multiplication. What the commutative property of addition says is that we can add two numbers in any order. So a plus b equals b plus a. In addition to that, there's a commutative property of multiplication which says that we can multiply in any order as well. So a times b equals b times a. So for example, 2 plus 3 equals 3 plus 2. We know that's true because 2 plus 3 is 5, and so is 3 plus 2. And 2 times 3 equals 3 times 2, because both sides equal 6. When you're trying to memorize what the commutative property of addition does, one thing to kind of keep in mind is that it switches the order around. So whenever you are trying to identify what property is being demonstrated, look to see if your two terms have been switched around in their order. I want you to realize also that there is no commutative property of subtraction or division, just for addition and multiplication. And the reason why it doesn't work for subtraction and division is because you can just pick a counterexample. For example, 2 minus 3 we know doesn't equal 3 minus 2 because 2 minus 3 is negative 1, 3 minus 2 is positive 1, and those obviously don't equal each other. So it doesn't work for subtraction. Likewise for division, 2 divided by 3 is obviously not the same thing as 3 divided by 2. So there is no commutative property for subtraction or division. Our next property that we're going to talk about is the associative property. There's one for addition and one for multiplication. And this is the one that students tend to remember as being the property that deals with parentheses. So what this property says for addition is that a plus b plus c in parentheses equals a plus b in parentheses plus c. In other words, it doesn't matter how we group together our terms, when we're adding, we'll get the same final result. So for example, 2 plus 3 plus 4 will equal 2 plus 3 plus 4. So we could add the 3 and the 4 first and then add 2, or we could add the 2 and the 3 first and then add 4, and no matter how we do it, we're going to get 9 on both sides. Similar rule for multiplication. It doesn't matter how we group together our terms. So for example, 2 times 3 times 4 would equal 2 times 3 times 4. So we could multiply together 3 and 4 first and then multiply by 2, or multiply 2 and 3 first and then multiply by 4. So the key thing to remember for the associative property is it allows us to shift parentheses around and rearrange our parentheses to contain different terms. So for example, up here the parentheses are around the b plus c, and we've shifted them to be around the a and the b. Okay? Our next property is the identity property, and there's again one for addition and one for multiplication. The identity property of addition basically says that we can take any number a and add 0 to it, and it gives us back a. And because of the commutative property, that also implies that 0 plus a gives us back a. For the identity property of multiplication, that property says a times 1 gives us back a, or 1 times a gives us back a. So I like to think of this as sort of the mirror property, the mirror image. You start with any number like 4, and if you add 0 to it, you'll still get 4 right back. Or if you start with 4 and you multiply by 1, you'll still get 4 right back. So whatever you start with, you also end up with. So that's the identity property. Notice that the identity element for addition is 0, and the identity element for multiplication is 1. So they're not the same. The next property that we have is the inverse property of addition and multiplication. And this one is what I like to think of as sort of a cancellation property. It starts us off with any number A, and in the case of addition, what do we have to add to A so that it cancels out? Well, we have to add its opposite. So for example, if I start with 4, I need to add the opposite, which would be minus 4, and then it'll cancel out to 0. For multiplication, we also want to cancel out our number, but this time our goal isn't to end up with 0. In the case of multiplication, we want to end up with 1 instead. So if I start with 4, what do I have to multiply it by to get to 1? Well, in this case, we're actually going to use the reciprocal. So if I start with 4 and I multiply by 1/4, I will cancel out my 4's and get 1 as an answer. So the inverse property of addition and multiplication is like a cancellation property. What do you have to do to get 0 or to get 1? When you talk about that inverse property, there's a little bit of vocabulary that pops up that you'll need to know about. And the first case here is the additive inverse, or what I have also mentioned as opposite. So when you talk about what is the additive inverse of A, or what is the opposite of A, that's just going to be minus A. So for example, if you start with 2, its additive inverse would be negative 2. If you start with negative a half, its additive inverse or opposite would be positive a half. So an additive inverse just switches the sign of your number and gives you the opposite sign. Now that's an additive inverse. If you talk about a multiplicative inverse instead, that doesn't switch the sign. That is the same as taking a reciprocal. So the reciprocal or the multiplicative inverse of A is 1 over that A. So for example, if I started with 2, then its multiplicative inverse would be 1 over 2, or a half. If I started with negative a half, then its reciprocal or multiplicative inverse would be negative 2. Notice here that when we do a reciprocal, all we're doing is flipping over the number, but the sign has stayed the same. So if I start with a negative, my reciprocal is also still negative. Okay? Now our last property that we're going to talk about is probably the most important one and the one that you use most often to simplify. And this is called the distributive property of multiplication over addition. And on this property, you've seen it before, I'm sure. What you start off with typically is a number out front of parentheses, and what we're going to do is distribute that number across the parentheses. So we're going to take this A and distribute it by multiplication to B, and then we're going to distribute it by multiplication across to C. So we end up with AB plus AC. So for example, if I have 2 parentheses 3x minus 5, this says take 2 times 3x, which we could simplify to 6x, minus 2 times 5, which we could simplify to 10. So our answer here is 6x minus 10. Now when you do the distributive property, you can do it in 2 directions. When we distribute this A across, like this, to get A times B plus A times C, that's multiplication. What we're doing here is we're multiplying the A across, and our eventual goal here is to get rid of the parentheses in the problem. Another version of the distributive property is actually to go in reverse. If you started out with 2 terms that looked like this, AB plus AC, there's no parentheses in that problem. But if you factor out the A, so pull A out like a greatest common factor, what you would be left with if you pull these A's out would be the B plus the C left over, and that's called factoring. So when you put the parentheses back into the problem, that's called factoring. So there's a difference between multiplication, which eliminates parentheses, and factoring, which puts parentheses back in. Okay, so let's practice the difference between these two with some examples. On this first example, I have parentheses in my original problem, so this must be a multiplication type of problem. So what we're going to do is get rid of the parentheses by distributing. Negative 2 times 4t is negative 8t. Then we're going to distribute that negative 2 across to the 3m, and what I like to do is take the sign in the middle and associate it with the 3m. So we're really taking negative 2 times negative 3m. Two negatives multiply to a positive, and 2 times 3m gives us 6m. So our final answer is negative 8t plus 6m, and we've eliminated all the parentheses. Okay, on the next example we're going to do the same thing. We're going to take negative 4, and in this case we actually have 3 terms in our parentheses. We want to eliminate these parentheses by multiplication. So I'm going to distribute my negative 4 across to all 3 terms. So negative 4 times positive 4z is negative 16z. Negative 4 times a positive 5w, there's only one negative there, so the answer is going to stay negative, and 4 times 5 is 20, so this would be negative 20w. And then on the last term, we're taking negative 4 times negative 9y, 2 negatives, multiplied to a positive, and 4 times 9 is 36y. So our final answer, negative 16z minus 20w plus 36y. Now on these last 2 examples here, notice there are no parentheses at all. So what we're going to do on these 2 problems is put the parentheses back in, and that is called factoring. So we're going to factor both of these 2 examples. Now when you factor, what you want to do is look at your 2 terms that you are given and find out what they both have in common. So when I look at 6x and x, they both have an x in common. So that's exactly what I'm going to pull out front in front of my parentheses that I'm putting in. Now when I take that x away, we want to figure out what would be left. So if I take out the x from 6x, I'm obviously left with just the 6. There's an addition symbol in between, so that's going to carry over to my parentheses. And when I go to the second term and I take away that x, it looks like there's nothing left. But I don't want to put 0 in parentheses, I actually want to put a 1, because think about how we could check our answer. If we redistribute the x back across, we should always end up with the original problem. And if I had 0 right here, then x times 0 would be 0, not the x that I need. So it has to be an x times a 1 to get me the original x that I have. So whenever you're factoring out your term and nothing is left, what you need to write down is a factor of 1 left over. Okay, so let's try this again. If we look at the next example, there's no parentheses, so I'm going to put parentheses into the problem. So I do that by looking at my 2 terms and deciding what they both have in common. And in this problem, they both are divisible by 2. So I'm going to pull out a 2 out front, and in parentheses we're going to write what's left over. Now we're really dividing both of these terms by 2. So when I divide out this 2, all that's left is x. Then we have a minus in the middle, and when I divide this term by 2, 4 divided by 2 leaves me with a 2, and that y will still be there. And you can always check your answer by redistributing back. 2 times x is 2x, 2 times 2y is 4y. So we got the right answer. And the last thing that we're going to do is a common type of example of looking at an equation that's a true statement and identifying which property is being demonstrated. So if we look at this first example, one of the properties that we talked about earlier is being demonstrated here. And you need to think about the different things that those properties allow us to do. So in this first example, one common mistake that students make is they see parentheses in the problem and they immediately think, oh, parentheses, that must be the associative property. Well, if you look more carefully, you'll see that this really isn't the associative property, because what the associative property does is it shifts your parentheses. So over here, in our parentheses, we have x plus 2. Over here on the right side, we still have that x and that 2 in the parentheses. It hasn't shifted to be around the 2 and the 3 like the associative property would allow us to do. So this isn't a shift. What's changed from the left side to the right side is that the order of x and 2 on the left is different than the order on the right side. So we've switched our order around. And anytime you switch your order around, that's the commutative property. So this is the commutative property. Now we don't want to just write commutative property. What we want to write is commutative property of the operation that's being used. And remember, there's either addition or multiplication. So in this case, since it's addition that's separating our x and our 2, this is the commutative property of addition. Okay, so let's try this again on the next example. You want to compare the left side to the right side. On the left side, what's in our parentheses is a y and a z. And on the right side, we also have a y and a z, but the order has switched. And again, if you switch order, that's always the commutative property at work. So this is the commutative property. But this time, instead of being for addition, since between that y and z is an implied multiplication, this is the commutative property of multiplication. Okay? On example number 3, we have x plus 4 plus y in parentheses equals x plus 4 in parentheses plus y. So this one is another example with parentheses. On the left side, the 4 and the y are in parentheses. And on the right side, the x and the 4 are in parentheses. So these parentheses basically got shifted over to contain the x and the 4. So we shifted parentheses. And that is the associative property. So this is the associative property. And the operation that's separating all these terms is addition. So this is the associative property of addition. Okay, example 4. We have 4 plus negative 4 equals to 0. So in other words, we started with a 4 and we canceled it out to get 0. So we basically have done a cancellation. And remember the property that was also known as a cancellation property? That is your inverse property. So this is an inverse property, and the operation that's being used here is that addition. So this is the inverse property of addition. Okay, example 5. We have x parentheses z plus y becomes xz plus xy. So that x got multiplied across to the z and the y. We distributed it across. So that is exactly the distributive property. And if you wanted to be a little bit more careful about your answer, you could say it's the distributive property of multiplication over addition. Usually instructors will let you get away with just calling it the distributive property, but its official name is the distributive property of multiplication over addition. Okay, example 6. We have xz plus xy equals xz plus yx. So the only thing that's changed on the left side and the right side is the xy turned into yx, and that's an order switch. And the property that causes you to, or lets you switch order around, is the commutative property. So this is the commutative property. But on this one you have to be a little bit careful about which operation is being used, because there's two operations. There's addition right here in the middle, but what we want to look at is the operation that's between the two terms being switched. This is x times y becomes y times x. So since it's multiplication between our x and our y, this should be the commutative property of multiplication. Okay. Example 7. 2/3 times 3/2 equals to 1. What happened here? We started with 2/3, we multiplied it by 3/2 to cancel it out and get that 1. So this is a cancellation property, which is another name for the inverse property. But this time we're using multiplication, because that's what's between our 2/3 and our 3/2, so that we can get to that identity element 1. So this is the inverse property of multiplication. We used that reciprocal. Example 8. 4 plus 0 equals to 4. So we started with 4, we added 0 to it, and we ended up with 4. So this is what I call a mirror image. You started with 4 and you ended up with that same mirror image back. That was called the identity property. So you're looking back at yourself, and the operation that's being used here is addition. Okay, our last example here says xz plus xy equals xy plus xz. So this one's a little bit tricky. There's no parentheses being used here, but what's changed is if you think of xz as a circle and xy as a square, then we basically have taken circle plus square and made it into square plus circle. And that's a switch of order. So all we've done is switch our order around. So this must be a commutative property. The tricky part is figuring out what operation is being used. And if you look at your circle and your square, what is the operation between the circle and the square? It's addition. So this is the commutative property of addition. Okay, so memorize those properties, and good luck. That ends the lecture on properties of real numbers.